Sir, I didn't get it.
Okay, no problem. So whatever I'm going to ask, just answer me. Do you know the formula of molarity that we denote with capital M? Just in
Oh,
fact, yeah, tell me.
weight of
It is number of moles of solute upon volume of solution in liter, right? This is the formula of molarity. And what is the formula of molality? Molality is denoted by a small m, and it has the formula number of moles of solute divided by mass of solvent in kg. Do you remember this? Yes or no?
yes, sir.
Okay. Now see, molality, we have given molality as 2m. What does this mean? 2m can be written as 2 moles per liter. This m is basically representation for molarity as well as unit. And m is equal to moles per liter. So we can easily write 2 moles per liter, right? Now you can see what is this moles? Moles is for solute. So we can also write 2 moles of solute. I'm just expanding this 2 moles per liter into 2 moles of solute in 1 liter of solution. In 1 liter of solution. Now you can see this is your formula for molality. This is your formula for molality, which is equal to molality is equal to number of moles of solute upon mass of solvent in kg. And here, from this information in the question of, just wait a minute, please.
Yes, sir.
Are you able to see the screen?
Yes, sir.
Now, you can see the information was given about the molarity from where you can get 2 moles of solute. That means to calculate molality, number of moles of solute is given with the help of molarity, that is 2 moles of solute. All we have to do is to calculate mass of solvent, and mass of solvent will be calculated with the help of density of the solution and also volume of the solution. You can see in 1 liter of solution, that means 1000 ml. This is your volume of solution, and density you can see it is 1.28 gram per centimeter cube. As we know that 1 centimeter cube is equal to 1 ml. So you can also write density is equal to 1.28 gram per ml. Now, you know the formula of density is equal to mass upon volume. Since we are applying the volume of solution and density of solution, so we will be able to get mass of solution because you are applying the value of volume of solution and density of solution. So what we will get? Mass of solution. So mass of solution will be equal to density of solution into volume of solution. Density of solution is 1.28 gram per ml into volume of solution is 1000 ml. Now you can easily see that ml and just wait a minute. ml and ml will be cancelled, right? Ml, this ml and ml will be cancelled, and when you are going to multiply it, you will be getting mass of solution, that is 1280 gram. Again, look at the formula of molality. Molality has a formula, number of moles of solute, that is already calculated number of moles of solute from here. And mass of solvent, you can see we need to calculate mass of solvent, but here we get mass of solution, right? So how you are going to calculate mass of solvent? You know mass of solution, since solution is equal to solute plus solvent. So mass of solution is equal to mass of solute plus mass of solvent. Mass of solvent. So mass of solvent is equal to what you will get? You will get mass of solution minus mass of solute. Minus mass of solute. You already know the value of mass of solution. All you need to do is to calculate mass of solute. And how you are going to calculate mass of solute? It's very easy, because number of moles of solute is given. Number of moles of solute is 2, and you know the formula of number of moles, that is given mass upon molar mass. And solute is what? NaOH. NaOH is your solute. It is determined in the question. Now you need to calculate this mass of solute upon molar mass of NaOH. If you are going to calculate, you will get 40 is equal to number of moles of solute 2. So mass of solute you are getting here is 80 gram. Now I think you will get it easily. Now you can see mass of solvent will be equal to what? Mass of solution that we had calculated 1280 gram minus mass of solute. What is the mass of solute? That is 80 gram. So you will get 1200 gram, or you can write 1.2 kg mass of solute. Mass of solute. Now again, I'm going to write the formula here. Molality has a formula, number of moles of solute upon mass of solvent in kg. Number of moles of solute already calculated, that is 2, and mass of solvent in kg, you can see mass of solvent is 1200 gram, that means 1.2 kg, and you can calculate this. You will get moles per kg, or you can write directly a small m. The process is lengthy, but you can do it easily. You need to understand the concept. So I would recommend you to please do write it in your way from here, and let me know if you don't get it. Very good question.
Yes, sir.
Please do write it. Basically, this topic you will again study in class 12, and that is solution chapter. Same topic will be revised, and then it will be stronger for you. I would recommend you to make it a strong in class 11 so that it will be very easy for class 12. Do a
Yes,
step
sir.
for done.
Yes, sir.
Each
So
and every
can you
yes.
scroll down?
Yeah. Siddhika, why you joined late? Okay. So we are just complete. We are just done with question 1, and we are going to take a screenshot of that question. It is easy but quite lengthy. Rishita, let me know when you are done with this.
Yes, sir.
So here is your next. Rishita, sorry, Siddhika, please take a screenshot of this question and let me know when you are done with this screenshot. Very good. Moving to the next question, which is very easy. If you know the formula of the concentration term, which of the following is dependent on temperature? Very easy question. Very good, Siddhartha. Any answer from you, Rishita?
Yes, sir. Molarity.
Yes, there is no confidence in your answer. So very simple it is. Volume is directly proportional to temperature. So what you need to do is just write the formula and see whether it has volume term or not. Molarity is equal to number of moles of solute upon volume of solution in liter. Mole fraction, number of moles of whatever is number of moles of A upon number of moles of A plus number of moles of B. Weight percent W by W. Uh, Basically weight of solute upon weight of solution in 200. And molality as a formula, number of moles of solute upon mass of solvent in kg. So you know that basically temperature has a direct relation with volume. So the concentration term which has volume term in their expression will be dependent on temperature, and which doesn't have volume term will be independent of temperature. So very good, both of you. This is a very good question, which is a combination of mole fraction and molality. The first question that I gave you was the combination of molarity and molality. It will not be solved only if you remember the formula. You need to know the concept. You need to know what is this capital M stand for. Like if there is 2M, that means 2 moles per liter. 2 moles of what? Solute. Basically, concentration term, we talk about concentration term in solution, and you know that in solution we have solute plus solvent. So please be careful, understand the concept and do solve it. Let me know if you are not able to solve this. Let's see what is there. Any any answer? Uh, Very good, Siddhika. Rishita waiting for you.
So
Second,
I got that the most. Should I divide it?
yes, you have to see the option whether it is in fraction or in decimal, and you have got the right answer. Okay, just divide it and let me know. Siddhika, go for question number 8. Very good, Rishita. Did you divide it or you just used calculator, Rishita?
So for this one, I just used the calculator.
No, you should not. Till class 12th, don't make it a habit or anything, because it's very easy to calculate with calculator. In NEET, you'll be getting questions of physical chemistry. There will be multiplication and division of decimal numbers. So it will be very hard to calculate at that time. So make a habit of calculating numbers, any numbers with your own hand. Use paper and pencil, please. Go for the next question. Very good, Siddhika. Rishita, what about you? Very good, both of you. Go for the next in this way. Yeah, Martin, finally you joined. Am I audible to you clearly? Martin, are you there? Please do
Yeah.
respond. Okay. So, Martin, I think you have already studied this chapter, some basic concepts of chemistry, and in the previous class you were not there, so you didn't know about the topic, the questions from which topic I'm going to ask. So if you are able to solve it, that is well and good. And if you don't, then don't worry. In today's class, I will let you know the topic that you need to revise, and we will be practicing questions for me there. Okay.
So can you explain the ninth one?
Yes. Siddhika, any answer? Martin, will you be able to solve this? See, there is nothing given except the density of solution. Okay, please do that. Rishita, focus here. Density of solution is 1.17 gram per centimeter cube cc. Now, you know that density is equal to mass upon volume. So you can also write 1.17 gram upon 1 centimeter cube. Can you write this, Rishita?
Yes, sir.
Now you can easily, now you have to extract information or the given value from here. This is what? This is your mass. So treat this as given mass. This is your given mass, and this is what? This is your volume. So this is your volume. Now, what you need to do, you need to calculate molarity. After extracting information from here, you are going to write the formula of molarity. Always write the formula before solving this, okay? In initial stage. Molarity as a formula, number of moles of solute upon volume of solution in liter. Now, you can solute is what? You can see the solute is given as HCl. So you can easily calculate the number of moles of HCl or solute. That is your given mass. That is given 1.17 divided by molar mass HCl. Chlorine has 35.5 atomic mass and hydrogen has 1. So it will be 36.5. This will be your number of moles of solute. Volume is what? 1 centimeter cube. Now you have to change this volume into liter. So what you need to do? Divide it by 1000, because if you want to convert ml into liter, you are going to divide it by 1000, and ml is equal to centimeter cube. So molarity will be equal to number of moles of solute is 1.17 divided by 36.5, and here you can see volume of solution is equal to 1 upon 1000. So you can easily solve this 1.17 upon 36.5 into 1000 upon 1. And here it will be basically 1170 upon 36.5. And if you are going to solve it, you will be getting 32.05 M. And Siddhika, that's correct. Martin, have you got it?
Yeah.
So please do write it. Yes, Siddhika. Everyone done with this question? Whenever you are done with any questions or theory, please do let me know. Please go for this. Martin, are you done with the previous question?
Yeah.
Wait a minute. Please do it. This question is very easy. Let me know if you are not able to solve this. Very good, Siddhika. Rishita, any answer? Martin, if you
Yeah,
don't
no.
know, what did you say? No or yes? Your voice is not clear, it's lagging. Rishita, what about you?
So 1 second.
Very good, Rishita. Okay, so Martin, you know what mole fraction? What is the formula for mole fraction? As I already told you that this concentration of mole fraction, molality, molarity, normality, weight by weight percent, all, etc. are for solution we use for solution. Let's say there is a container in which we have two components. You know that solution, we prepare solution at least from two components. Okay, so let's say there is A and B, or water or sugar, you can say. A has number of moles Na and B has number of moles Nb. So the mole fraction of A will be equal to number of moles of A upon total moles in the solution. Total moles is number of moles of A is present as well as number of moles of B. So this is your mole fraction of A. Mole fraction of B will be equal to number of moles of B upon number of moles of A plus number of moles of B. So see, whenever you are going to divide it, the numerator is always greater than the denominator is always greater than the numerator. So the value will be between 0 to always greater than equal to 0 or less than equal to 1. Always less than 1 it will be. But if you are going to add both of them, mole fraction of A plus mole fraction of B, it will be equal to 1. Because what you are doing, you are just, if you have a bread, you are going to divide it into equal parts, and if you are going to add them all, you will get 1. Got it? Martin, please do solve this. Any answer for this question?
There was a previous question answer.
A. Small fraction cannot be greater than, it is between 0 to 100%. Good, Rishita. And Sisudhiga. Very good. Martin, any answer for this question? Last question. Yes or no?
We'll find the molarity.
Yes. You know the formula of molarity. Molarity has equals to number of moles of solute and volume of solution in liter. Now you can see volume of solution is given as 100 ml. So you just need to convert this ml into liter. So you need to divide this by 1000. Now you just need to calculate number of moles of solute. You have three formulas to calculate number of moles. Now, if you have number of particles given, number of mole will be equal to given number of particle upon Avogadro number. Given number of particle is 6.02 into 10 raised to the power 20 upon Avogadro number is 6.02 into 10 raised to the power 23. So if you are going to divide this, you can see you will be getting 10 raised to the power minus 3 moles. So I'm just going to put the value here 10 raised to the power minus. Now what you need to do, it's very simple. 0 and 0 will be cancelled, 0 and 0 will be cancelled. And now you can see 10 raised to the power minus 3 divided by 1 upon 10. This 10 will come into this and multiplied by this. 10 raised to the power minus 3 into 10 raised to the power 1, that will be equal to 10 raised to the power minus 2, and it will be equal to 0.01 m. And hence the correct option that we have is A. Got it? Let me know when you are done with this. Martin. Moving to the next question. This is a question of stoichiometry, and it is a very good question. Very easy. You have to write the reaction first. 10 gram of hydrogen, 64 gram of oxygen. That means hydrogen and oxygen is going to react with each other. They are filled in a steel vessel and explode. So when they are going to react with each other, water will be formed. So you have to write a reaction. The reactants are hydrogen and oxygen, and the product is water, and you have to balance it as well, and then you can solve it. Let me know when you are done with this. No, Rishita, it's wrong answer. Any answer from you, Sabita and Martin? Okay, I'm going to explain. See. Okay, take your time, Sabita. I'm just giving you one more minute, 2 minutes. Rishita, please do check it. Rishita, please do check it. So I'm going to explain. See, Rishita, hydrogen and oxygen is going to react with each other. They are filled in vessel and then explode. That means the water is formed. Then it explodes. Now see, you need to balance it, and in order to balance it, oxygen is 2 on the left hand side and oxygen is 1 on the right hand side. So I'm going to multiply it by 2. So oxygen will be balanced, but hydrogen is now unbalanced. So I'm going to multiply it by 2. Now the reaction is balanced. Okay. Now it is also given that this is your 10 gram and this is your 64 gram. Now you need to calculate always whenever anything is given like mass, volume, number, you need to calculate moles first. So the number of moles given mass upon molar mass, hydrogen has molar mass H2, that is 2. So it will be 5 moles, and here you can see given mass 64 and molar mass you can see one oxygen has 16, so 2 oxygen will have 32. So the moles will be 2. So I'm going to write it down. This is your 5 moles and this is your 2. So now we are going to read the question. What we need to calculate. So here 10 gram hydrogen and 64 gram oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be. What will be the amount of water? And since number of mole is given in the option, so we need to calculate the number of moles of water formed. So see, whenever the question is based upon stoichiometry, whenever the question is like this, you need to calculate, you need to see which one is limiting reagent. If there is any limiting reagent, if there is any limiting reagent, then you can easily relate any reactant to the product. Oh, sorry. If there is no limiting reagent, if there is no limiting reagent, there is no limiting reagent, that means all the reactants are used, so you can easily relate any reactant to the product and calculate the number of moles of the product or amount of the product formed. But if there is limiting reagent, then the product will be decided on the basis of limiting reagent. How we are going to calculate, or how we are going to recognize which one is limiting reagent? So it's very simple. What you need to do is very simple. Whatever is the number of moles that you have calculated from the information that is given in the question, you are going to put this in numerator, and whatever is the number of moles in the balanced chemical equation. This is a stoichiometry in which this is called a stoichiometric coefficient, and this represents number of moles. Okay, so you are going to divide this. Here what we have 2, and number of moles here you can see it has a stoichiometric coefficient 1, so you are going to divide it. Now the ratio which is smaller will be the ratio which is smaller will be the limiting reagent. Now you can easily understand that this is your 2.5, which is greater than 2. So the smaller one will be your limiting reagent. Are you getting my point? Everyone, Rishita, Martin?
Yes, sir.
Yeah.
Now, what I told you, when you get or when you recognize which one is limiting reagent, you are going to prepare the product according to that limiting reagent, not the one which is not limiting reagent. The other reactants will be in excess. Okay. Now see how you are going to calculate it. This is a balanced chemical equation, so you are going to compare with this. So you can see from 1 mole of oxygen, you are getting 2 mole of water. Yes or no? This is how we read in a stoichiometric concept. 1 mole of O2 gives you 2 mole of H2O. What we have actually, 2 moles of oxygen will give how many moles of water? 4 moles, because 1 mole of oxygen is giving you 2 moles of water. So 2 moles of oxygen will give 4 moles of water. This is unitary method. If you are getting 2 chocolate from 1 rupees, so you will get 4 chocolate from 2 rupees. Getting my point, all of you? Rishita, okay, please do write it.
The answer is 2 more of 4.
What did you say? Actually, we calculated 2 moles. So the final answer we have, we need to calculate the amount of water, 4 moles. We just confirmed that which one is limiting reagent. So oxygen is limiting reagent. So according to balanced chemical equation, 1 mole of oxygen gives you 2 mole of water, 2 mole of water. And how many moles of oxygen we had? We had 2 moles of oxygen. So if 1 mole of oxygen will give you 2 moles of water, so 2 moles of oxygen will give us 4 moles of water. 4 moles of water. Got it? Martin,
Yeah.
please do it and let me. Can I change the slide? Rishita, are you still writing? Oh, okay, Siddhika. Yes, Rishita, come again.
No, sir, I am done.
Good. Okay. What about you, Martin?
Yeah. Continue.
Please do this last question.
So it's 4 moles.
Only this much question. This is the last question. What did you say?
So it's 4 moles. 4 moles.
Yeah, 4 moles is the answer. Let me know when you are done with this. See, I'm going to explain this. 22.4 liters of H2 is mixed with Cl2. You will get what? HCl. You need to balance this. You are going to write fluids. Now, according to the question, we can see we have 22.4 liter of hydrogen gas and 11.2 liter of Cl2. Now, what we need to do, what I told you, whenever this type of question is given, you need to calculate number of moles. So, number of moles will be equal to given number of given volume upon 22.4 liter. And here you can also do the same, given volume upon 22.4 liter. Now, what is the number of moles of H2? Here you will get 1 mole, and here you will get 0.5 mole. Now, again, you have to check whether which one is limiting reagent and which one is in excess. So, what you need to do, you just need to divide this with a stoichiometric coefficient of the balanced chemical equation. So, 1 by 1, and here you can see 0.5 divided by what? Here it will be 1, so it will be 1. You can see H2 is greater than Cl2, so this is our limiting reagent. Are you getting my point, everyone? Siddhika, Rishita, we need to
Yes.
calculate HCl formation. Now, this is your limiting reagent, so the product formation will be decided on the basis of limiting reagent. Now, you can see 1 mole of Cl2 will give 2 mole of HCl, 2 mole of HCl. And how many moles of Cl2 we have? Half mole. So, what is the number of moles of HCl formed? 1 mole of HCl. This is very, very easy. Basically, it's just unitary. You can see 1 mole of Cl2 gives you double 2 moles of HCl. So half mole of Cl2 will give you double of half, that is 1 mole of HCl. Okay. Is that clear, everyone?
Yes.
Okay, so this is it for today. In the next class, you are going to cover this part as well. I'm going to write again. There will be some standard question of concentration terms. We are going to do some more questions on stoichiometry. Today's class is based more questions on concentration term, but the next class will be specifically for this stoichiometry. And there is also empirical formula. Also, you can go for mass person. Okay. So this is what we need to do. We need to do in the next class. The questions on this topic. Please do write it. The topic. And then I'll see you in the next class. Okay, everyone. So this is like